Today, friends, today see verification of second law of vibrating string or law of tension. Now again, this is the figure of sonometer. Figure of sonometer. Again, this is a sonometer. In this sonometer, it consists of a rectangular wooden box. This wooden box having 2 or 3 holes. This wooden box is called as sound box. On this box there are 2 bridges and we have taken a metal wire of uniform cross section which is fixed at one end. Another end of the wire passes over the bridges and pulley, and free end we have hang a hanger and attach the weights to that hanger. Now we see the verification of second law of vibrating string. In this second law statement, second law, the fundamental frequency of vibrations of a string directly proportional to the square root of tension if L and M are constant. What is the fundamental frequency of vibration of a string directly proportional to the square root of tension if length and mass per unit length are constant? That's why N directly proportional to under root T if T and M are constant. This is the statement of second law of vibrating string. Now here we can show that N is directly proportional to under root T. See here in this figure we have taken a tuning fork. And that tuning fork hammer on the rubber pad and set into vibration. In this condition, this tuning fork hold near to the wooden box with its stem, and we can fix the length between the 2 bridges, and which is kept constant throughout the experiment. Now we can take then we put a paper rider at the center of the bridges, and now we can set the tuning fork into vibrations by hammering on the rubber pad. In this mode we can hold the tuning fork near to the wire, and now this tuning fork exerts the force on the vibrating length of the string. If we have select a set of tuning fork of frequencies N1, N2, N3, N1, N2, N3, then N3 and corresponding tensions T1, T2, T3 are noted. Then N1 upon under root T1 equal to N2 upon, then it is observed that N1 upon T1 equal to N2 upon under root T2, N3 upon under root T3 equal to constant. Means N upon under root T equal to constant. See here, now we have taken a set of tuning forks N1 and we have adjusted the weight to the hanger T1 and made the length constant, and mass per unit length is also constant, so that when the frequency of tuning fork exactly equal to the frequency of vibrating string, then string vibrate with maximum amplitude and paper rider is thrown off or fall down. In this case, note the length of the vibrating string. In this case, note the tension of the applied tension to the string, that is T1. So that frequency is N1, tension is T1. So it is observed that N1 upon under root T1. Then again, we take the another tuning fork of different frequency. Suppose N2. Then again, this is length is made constant, same length, but we have changed the applied tension. Suppose it is T2. We have applied the tension T2. We have changed the tension. Length is constant. Mass per unit is also constant. Means wire is same for same wire. Again, made the same experiment. We have kept paper rider at the center of the string and take a tuning fork, set it to vibration, held near to the wire. Then when the frequency of tuning fork equal to the frequency of vibrating string vibrate with maximum amplitude, paper rider fall down, then note the tension T2. Suppose T2. It is observed that N2 upon under root T2. In this way, we can take the another tuning fork and for another tension by making length constant and for the same length, and then it is observed that N3 upon under root T3 equal to constant. Therefore, N upon under root T equal to constant. This is the verification of second law of vibrating string or law of tension. It is also called as law of tension. Means in law of tension, what happens? The fundamental frequency of a vibrating string is directly proportional to the square root of tension if length and mass per unit length are constant. So this is the second law of vibrating string. Now we can see the third law of vibrating string. Third law of vibrating string. Third law of vibrating string or law of linear density. Law of linear density. Now, statement. The fundamental frequency of vibrations of a string is inversely proportional to the square root of mass per unit length. Mass per unit length if L and T are constant. Length and tension are constant. Then N is inversely proportional to under root mass per unit length if T and L are constant. This is the third law. What is the statement of third law? The fundamental frequency of vibration of a string is inversely proportional to the square root of mass per unit length if L and T are constant. Means N fundamental frequency is inversely proportional to the square root of mass per unit length or linear density if T and L are constant. So again, in this case, again we can repeat the same experiment, but in this law, means law of linear density, we can use two wires, M1 and M2. We can choose two wires, M1 and M2, and for corresponding frequencies. Again, we can make the tension is constant and length is constant. Tension is constant and length is constant. But here we can select or consider two wires of mass M1 and M2. M1 and N2. M1 and N2. M1 and mass M1 and M2. Mass M1 and M2. So that the corresponding length are L1 and L2. Then it is observed that L1 under root M1 equal to L2 under root M2 equal to constant. Means L under root M equal to constant. L under root M equal to constant if N and M are L are constant. If N and T are constant. L and M equal to constant. Now see here, for third law of vibrating string or linear density, we can change the wires. Means we can use two wires M1 and M2. Means we can change the linear density, and so that for the same tuning fork, we can change the corresponding length. And we know that repeat the same procedure, then take the tuning fork, set into vibrations, and when the paper rider is fall down, note the corresponding length, so that when the masses M1 and M2 corresponding lengths are L1 and L2, then it is observed that L1 under root M1 equal to L2 under root M2 equal to constant, and therefore L under root M is constant according to first law. According to first law, N inversely proportional to 1 by L. Therefore, N is 1 by under root M if T and L are constant. This is the third law. So we can verify the first law of vibrating string, second law of vibrating string, and third law of vibrating string. So these are the three laws of vibrating string. What is first law? Law of length. Second, law of tension. Third, law of linear density. By using sonometer. It is very, very clear and very, very easy. So stop here. Thank you.